Now let us take the question number 4. Examine the consistency of the system of equations x plus y plus z is equal to 1, 2x plus 3y plus 2z is equal to 2, ax plus ay plus 2az is equal to 4. If you observe this system of linear equations, these are the equations in the variables x, y and z. The concept was extended to 3 variables. In the previous question, we have discussed only the pair of linear equations in 2 variables, whereas here this system of linear equations are in the variables x, y and z, 3 variables. Okay, my children, understood the question? Now we follow the same procedure, same stages. We follow the same stages also. Understood, my children? The system of equations can be written in the form Ax is equal to B, where A is equal to matrix 1, 1, 1, 2, 3, 2, A, 2, A. Means it is a coefficient matrix. Previously I told you A means here coefficient matrix. Coefficient matrix means the coefficients of x, y and z. Coefficient of x is 1, here coefficient of y is 1, coefficient of z is 1. So 1, 1, 1. The second equation, if we observe, coefficient of x is 2, coefficient of y is 3, coefficient of z is 2. So we wrote the coefficients of the x, y, z in the second equation as a second row. Now come to the third row. From the third equation, we write coefficient of x, coefficient of y and coefficient of z, a to a. We wrote these three as the third row. Understood, my children? Now come to the x. X means variable matrix. What are the variables in this system of equations? X, y and z. So we wrote that matrix, variable matrix. And B is equal to, what I said, B means constant matrix. What are the constants in the RHS? 1, 2, 4. 1, 2, 4. Understood this step, my dear children? This is the first stage. The second stage is we have to find det A. So we have to find the determinant of this coefficient matrix. So det 1, 1, 1, 2, 3, 2, A to A. You know how to find determinant of a 3 by 3 matrix. You can expand the determinant along R1 or along R2 or along R3 or along C1 or along C2 or along C3. Before that, just I applied the properties of determinants. If you are taking any coefficient, any factor common from any row, we can write like this. By taking the common factor a from the R3, we get a into det 1, 1, 1, 2, 3, 2. In the third row, if we are taking a common factor, we get here 1, 1, 2. Understood this step, my dear children? Just I have applied the properties of determinants here. Otherwise, we can expand this determinant directly along R1 or along R2 or along R3 or along C1 or along C2 or along C3. We can find in that method also. No problem. Understood, my dear children? Right. Now I am expanding the determinant along R1. Then we get that A is equal to A into 1 into 3, 2, 1, 2. We get here the submatrix. We have to find the submatrix determinant. Okay, my children. See the matrix here. See this matrix. From this matrix, we close the first row and first column like this. What will you get the submatrix? 3 to 1, 2. So I wrote here that 3 to 1, 2. Next minus. I told you plus minus plus in the first row. Sign matrix. Remember that sign matrix. Now this element, we write this element as it is. Into, we will close this first row and this second column. What is the submatrix we get here? 2, 2, 1, 2. We have to find its determinant. 2, 2, 1, 2. Okay, my children. Next sign is plus sign. And we write this third element in the first row. 1. We wrote as it is. Now we have to close this first row and third column. What will you get here? 2, 3, 1, 1. So we have to find its determinant 2, 3, 1, 1. Understood this step, my dear children? Right. Now we find the value of this expression. So that is equal to a into 1 into 3 into 2 minus 1 into 2. Okay, my dear children, minus 1 into 2 into 2 minus 1 into 2 plus 1 into 2 into 1 minus 1 into 3. Understood this step, my dear children? Right. That is equal to a into 3 2's. What will you get here? 6 minus 1 into 2. What will you get here? 2 minus in these brackets. What will you get? 2 into 2 4 minus 1 into 2. What will you get? 2 plus in these two brackets 2 into 1, what will you get? 2 minus 1 into 3, what will you get? 3. Understood this step, my dear children? Right. That is equal to a into, in these brackets, what will you get after simplification? 6 minus 2, 4. Here, what will you get? Minus 2. Here, what will you get? Plus 1. Understood this step, my dear children? Right. That is equal to a into, by simplifying these three terms, what will you get here? 3. Understood this step, my dear children? Right. That is equal to 3a. Now, if you observe here, delta is equal to 3a. Here we are not getting a numerical value because here a is unknown quantity. So here two cases arise. The first case is if a is not equal to 0, if this value a is not equal to 0, so the entire value is also not equal to 0, then delta is not equal to 0. Understood this line, my dear children? Hence, the system of equations is consistent and has a unique solution. In the first case, if you assume that a is not equal to 0, then delta is also not equal to 0. Then we can say that the system of equations is consistent and has a unique solution. Understood this first case, my dear children? Right. Now come to the second case, case 2. If a is equal to 0, if a value is 0, then delta is also 0. So we need to calculate adjoint a into b. If delta is equal to 0, we have to check that adjoint a into b is a 0 matrix or not a 0 matrix. For that, first we have to find adjoint a. Here I am finding adjoint a directly. Okay, my children, see here. This is the matrix A. Matrix A. This is matrix A. You have to remember the sign matrix plus minus plus minus plus minus plus minus plus. So first we keep that signs plus minus plus minus plus minus plus minus plus. First to keep these signs. Next we have to write the submatrix. So here we have to close the first row and first column. First row and first column. What will you get here? 3 to A to A. 3 to A to A. 3 to A to A. Here A means 0. Here we assume that A is equal to 0. Then its value also 0. So 0, 0. Okay. Next second element. So close the second element here. So first row and second column. What will you get? 2 to A to A. These are all zeros. A to A. These are all zeros because A value is considered as 0. So by closing the first row and the second column, what will you get? 2 to 0 0. I wrote here 2 to 0 0. Understood, my dear children? Right. Now come to the third element in the first row. Close the first row and the third column. What will you get? The submatrix 2 to 0 0. So 2 3 0 0. Understood these three elements, my dear children? Right. Similarly, we write second row elements and third row elements. Understood how we wrote the first row elements? Similarly, write the second row elements and third row elements by closing that second row and first column like that. Understood? Whole transpose. Here we are finding the cofactors of the total 9 elements. Okay, my children, this is nothing but the cofactors matrix. It's a transpose. If you are taking transpose, then we get adjoint A. Understood, my children? That is equal to here plus 3 into 0 minus 0 into 2 minus of 2 into 0 minus 0 into 2 plus 2 into 0 0 into 3. Understood, my children? The first row elements. Similarly, second row elements minus 1 into 0 minus 0 into 1 plus 1 into 0 minus 0 into 1 minus 1 into 0 minus 0 into 1. Understood these elements in the second row, my dear children? Right. Now come to the elements in the third row. Plus 1 into 2 minus 3 into 1 minus 1 into 2 minus 2 into 1. Okay, my dear children? Plus 1 into 3 minus 2 into 1. Understood these three elements in the third row, my dear children? Right. Now we simplify these elements. Here we get 0. Here also we get 0. Here also we get 0 in the first row. In the second row also we get 0 after simplification. Here also we get 0. Here also we get 0 after simplification. In the third row we get here minus 1. Here we get 0. And here we get 1 after simplification. Now we have to take its transpose. Do you remember what is meant by transpose of a matrix? Right. We have to interchange the rows and columns. Okay, my dear children? Right. Therefore, adjoint A is equal to matrix 0, 0, minus 1, 0, 0, 0, 0, 0, 1. After taking the transpose of the previous matrix, we get here adjoint A. Understood this step, my dear children? Right. Now we can calculate. We have to calculate adjoint A into B. Okay, my dear children. Now we are finding adjoint A into B. What is the adjoint A? 0, 0, minus 1, 0, 0, 0, 0, 0, 1. I wrote this matrix as it is. Here I am writing the B matrix. Now we have to multiply these two matrices. You know how to multiply two matrices. You have to take the here first row. Here first column. After that first second row. First column. Third row. First column. Like that. So 0 into 1 plus 0 into 2 plus minus 1 into 4. This is the element in the first row. Second row. So here we write second row only. So 0 into 1 plus 0 into 2 plus 0 into 4. This is the second row element. Next we are taking third row. So we should write here third row only. So 0 into 1 plus 0 into 2 plus 1 into 4. This is the third row element. Now we simplify these numbers. Then what will you get here? 0 plus 0 minus 4. Second element is 0 plus 0 plus 0. And third element 0 plus 0 plus 4. Again after simplifying these three numbers, what will you get? Minus 4, 0, 4. Is it a zero matrix? What is meant by zero matrix? Every element in the matrix should be 0. But here these two are non-zero elements. So it is not a zero matrix. Understood, my children? Now here the equations are said to be inconsistent with no solution because we are not getting a zero matrix. Here adjoint A into B is found. In that case we did not get a zero matrix. So we say that it is a inconsistent with no solution. Understood, my children? Right.